speak with you guys tonight. My name is Ken Sullivan. I am Global Key Accounts Manager for ST, responsible for Microsoft. On the phone we have Eduardo Galizio. He was responsible for putting together our IoT strategy, and a lot of that involves the Nucleo system that we're going to be introducing to you guys tonight. So the agenda for tonight, we'll do some introductions. Obviously, we're right there. We'll give you guys kind of we're going to do a brief overview of the ST Micro. I'm not going to spend too much time. I'll try not to kill you with PowerPoint slides here. And then Eduardo will give you a brief overview of the STM32 or MCU ecosystem. And then we'll hand it over to Slim, whom I'm sure will captivate you with his knowledge and demonstrations. So, with no further ado, for those of you, is everybody pretty familiar with who ST is? So, for those of you that aren't, we're a global semiconductor company. We've been in business for quite a few years. Last year we did about $7.4 billion in revenue. Largest European semiconductor company. It was a combination of, for some of you guys that have been around for a while, Thomson Electronics and SGS. An Italian company and a French company coming together and created STMicro. So it's an interesting ride. It makes it a fun company to work for. About 43,000 employees worldwide. 8,700 in R&D, so there's a huge investment on ST's part for research and development. So we're constantly coming up with a variety of things, trying to stay on top of the technology, the future technologies. And we'll show you a little bit about that later on. Of course, listed on the New York Stock Exchange, Euronext, and Borsa Italiana Milano. Where you'll find us, a variety of things. Our MEMS sensors are in everything from cameras to fitness bands, tablets, phones. You'll find our digital consumer products in set-top boxes. We do a variety of ASICs, very, very high-tech ASICs. You'll find our products in a lot of cars, both in the US and in Europe. Smart power products powering mobile devices, as well as like street lamps, and so we're heavy into LED lighting power. And of course our microcontrollers, to say the least. We have two main segments of the company. One is Sense, Power, and Automotive products, which involve our analog MEMS and sensors, our automotive product group, which is a variety of different products, and our industrial power and discrete groups, IPD. And then we have our embedded solutions group, covering our digital convergence products, imaging, and microcontrollers. As I mentioned, we've got manufacturing facilities all over the world, so we're captive. We're not a fabless semiconductor company. We have our own fabs, our own back ends. Not that we don't use third parties, but we pride ourselves in being able to own our technologies. So it makes us a lot more competitive and a little more nimble than most companies. As I mentioned before, we're extremely committed to R&D. We have research dev centers all around the world, 15,000 patents in 9,000 patent families, and just this last year, 500 new patent filings. And as I mentioned, 8,700 people working in R&D for product design. Sales offices, again, all around the world, 35 different countries. 79 different sales offices, all our own offices. So, our vision is everywhere microelectronics make a positive contribution. That's where we want to be. Our strategy is leadership in sense and power automotive products and our embedded processing solutions, those two groups that I mentioned. These are the 5 growth drivers in that in our strategy: smart power, MEMS and sensors, automotive microcontrollers, and digital consumer electronics. So that said, Eduardo Galizio, who's coming to us from Chicago. How's the weather there, Eduardo?
Yeah, hello to everybody and good evening. It's freaking cold, honestly. So I'm 24, so I'm somewhat used to this, really cold temperature. But since yesterday I'm here for some, training and internal meeting. So I apologize if I cannot be there live, but definitely it's a pleasure for me, and it's a pleasure definitely for ST to be invited and to present, let's say, how we can help with some, embedded solutions, and even more with this ecosystem that we have created and we are expanding for the IoT. So maybe, Slim, if you can go ahead. So, in short, the idea of presenting this is, behind it is, as usual, a marketing and a business reason, right? So we see a big opportunity, and I have understood that most of you guys are also part of this opportunity because you are developing basically embedded systems, okay? Either with ARM or not yet with ARM-based solutions. And the big opportunity for ST is that we have really a broad portfolio that is covering, let's say, a lot of applications out there. And we can offer, as Ken was already, introducing before, different sensors, really a big portfolio of sensors, and the ST here is really the market leader with MEMS sensor and microcontrollers. We have processing, and you will go later in deep details with Slim on our STM32 family. We have also connectivity solutions, including BLE or double gigahertz, and also Bluetooth or Wi-Fi modules. We have then all the analog group that is around the processing of the sensors, and then smart power management. So really, all the ingredients that are necessary for most of the IoT applications. This is what ST can offer today with the current portfolio. So moving forward, here are some more details really on the different building blocks that ST can offer from the process. And here we have, really the biggest family in the market of ARM-based 32-bit microcontroller. On the sensor and the actuators, here a big family of different solutions from motion MEMS, environmental MEMS sensors, MEMS microphones, so audio sensor, let's say, touch sensor, again here addressing different applications from small to big screen. Then microcontrollers, and this again is something maybe that is not very familiar and still maybe not very known, but our micromirror technology can really enable disruptive applications. And then proximity and image sensors to complete the family. Around, then you need to power, and you need to translate everything that comes from the sensor, go to the processing, etc. So this is in short, in a couple of slides, the overall portfolio that ST can offer today. Moving forward, the message is how we can enable, right, all these solutions that ST has in an easy and affordable way, let's say. So addressing IoT, again, with a variety of solutions means not only offering hardware, okay, but means, in our view, and the reason behind is that the STM32 ecosystem has been also to offer development tools. And development tools means hardware and means also software. So later Slim will show really real examples in using our Nucleo board and some of the extension boards that are offering, sensors or BLE connectivity that can complete really your proof of concept and can give you an easy, very quick way to put in place an idea and to realize a prototype, a proof of concept. We are addressing really different market segments and we can be addressed different verticals with this portfolio. Here are some more details on how this ecosystem is conceived and how it can work. So the idea is the core is basically an STM32 Nucleo, and in the STM32 family we have today more than 600 different part numbers, ranging from Cortex-M0 till powerful Cortex-M7 that is really on the high end and really borderline with an MPU. And around these Nucleo boards, what we can offer today is a variety of extension boards offering sensing capability and offering connectivity in order to transmit the data gathered from the sensors. We can offer, power management and like battery monitoring, etc., etc. So the idea is you can take these multiple boards, you can hook one into the other, and then once, thanks to Slim, once you have, let's say, these hardware components put together, here there is a picture also of an NFC tag, okay? So NFC is becoming more and more popular since, last September when Apple announced that they will support also NFC. We have, again, there a complete portfolio ranging from a simple passive tag to a more complex transceiver. Anyway, so the idea is leveraging on ST-wide product portfolio. The idea is to offer really inexpensive, because these boards basically are extremely affordable, so they range between $10 to, let's say, 25 or 30 bucks, okay? And they offer the possibility really to build in 15 minutes a proof of concept of your idea or the target application. I didn't mention at the beginning, if you have any questions, if something is not clear, please stop me anytime, okay? So on the Nucleo and on the STM32, this is one, I believe, of the key areas where we can help and where maybe your interest is definitely focused. How we can help? So definitely here we can help with a full range of products, from the ultra low power to the mainstream or even entry-level microcontroller, so an F0 family, till up to an F7 that is the latest product family that we have introduced, the STM32 board. So the idea is we can really intercept all the possible applications that you might have in mind. You can see here some number in terms of clock that you can, the speed that you can clock these different microcontroller family, and also the limits that we can offer with the different products. Inside each of these product families, from an L0 to an F7, we have multiple part numbers coming with different packages, different memory size, different peripherals, etc. Moving forward, so the idea is, so once you take those hardware building blocks that I mentioned before, selecting one of the microcontroller that is matching your needs and your target spec. After that, you go online, you download a software that is, as we call STM32 Cube, okay? That is basically a free of charge, expansion software that is offering, all the low-level libraries and up to the abstraction layers, okay? To enable developers like you guys to be up and running with an hardware and software tools in literally minutes. After that, this is compatible with a number of development environments, okay? And recently we have also announced, a proprietary free compiler, ST compiler for that. But then around our STM32, we have also a big community, okay, of developers and tools, including then documentation, application notes. There is an E2E forum that is available, and on many topics is pretty popular. So definitely we are offering a big product family, an ecosystem of components around our STM32 Nucleo, and most important, so if you move on, Slim, the idea that everything that you can develop is portable. So the Cube MX configurator enables you to, you will see later a real example, to pick the device inside the product family that you are targeting, then to decide which is the package, which is the memory size, etc., and in a very easy way, with a graphical user interface, to immediately have all the peripherals checked, to decide which is the configuration, and really to build your application on top on these libraries or on the SDK that we provide along the connectivity solutions that we have. So the idea is offering an easy way. So our marketing message is we would like that it takes 15 minutes for you to be up and running with our hardware and software, and then you can take the next 15 months to develop and to realize your application. The Cube, we believe, and the feedback that we have received from different developers is pretty powerful, because it offers the possibility to configure the clock, to have a real-time check on the pinout of the system, and then this gives you the possibility to generate the source code, okay, based on that specific micro that you have picked, based on that specific configuration that you have selected, with those specific peripherals that you need to develop your application. So these snapshots really are showing something that you will see later live. Another important aspect is really here, showing some examples of expansion boards, right, that are today available. You can buy, these through, ST website, or through, DGT or our distributors. So the idea is really to offer these expansion boards with, different connectivity, NFC, Bluetooth Energy. We will release, in a month, also sub-1 GHz expansion boards with motion and environmental sensors, with stepper motor driver. So we believe with these ingredients you can really prove if some of your ideas are viable, and then you can develop really your application inside that Nucleo board that we were talking about before. So the sensor board, just to give an example, comes with 4 different sensors, and can be plugged in, in one of the Nucleo boards. That's perfect. I mean, as you prefer. So here I will just mention the different sensors that are on board this expansion.
Okay.
Sorry, is there any question?
No.
Okay, so perfect. So no, really different sensors on board, and one of the key messages that comes also along with this is that ST is offering a professional-grade sensor fusion that can be evaluated and used with exactly this STM32 Nucleo ecosystem that we are talking about. So moving on to the next one, here there is a summary of the multiple STM32 Nucleo boards covering really all the product family that we have announced and we have today available. The key features are, the integrated debugging and programming probe. There is, an Arduino connector in order to enable also additional, expansion boards to be used, okay? And really, the idea is you pick the Nucleo that is matching your specs, and then you build around it your proof of concept. So moving to the next slide, here you can see some more details on that, sensor expansion board. When you have, a 6-axis accessible gyro, you have a mag, you have a pressure sensor, so an altimeter, a humidity sensor, and then there is also the possibility to plug an additional daughter card for the newer sensors that we are adding inside our portfolio. Moving on, here is what I was mentioning. So ST announced last November this, we believe, very important initiative. In fact, is receiving a lot of good feedback from the market, from developers like you guys. Open.mems, so basically is offering the possibility to download and to use a professional-grade sensor fusion with 6 or 9 axes, depending what you have in mind. And this can really enable to bring your ideas to life with the STM32 Nucleo ecosystem. So the idea is you get a Nucleo board, you get the sensor expansion board, you go online, you need to recognize your Nucleo is based on a license for the specific node that you have, and then you will receive a license number that you can use and you can evaluate for free all these software plus hardware. So this is available. This enables you to go quickly in production, and then so if you can go ahead, Slim. So the idea is that once you have evaluated and you have realized that you can match your needs, the idea is you will need additional support from ST, but this is again available because we are offering for all these expansion boards schematic, PCB layout, and application notes, how you can bring up, right? So if you're expert on the processing side, and you're not expert on the sensor or on the other peripherals and components around that, I believe we can help and with collaterals and other materials available online. I think that's pretty much all. So the message is, here you can see the full set of expansion boards that are all available today or will be available in the next month. So you can see really the full range of components that we are offering. And the idea is, from a software point of view, the flexibility and the scalability that we offer through the Nucleo family is pretty significant. So all the Nucleo boards are basically supported by Mbed as well. And so tools that are available, application example like SDK, as I was mentioning, for the DAV case, for instance, and then going down to the middleware and the low-level libraries for USB, etc., that we are releasing inside the Cube package. So really, this is released in source code with a permissive license. And so with these, we are really addressing and serving, different vertical markets where, again, here are examples. So then I let you to your creativity put together what you believe can be significant for your professional life or even just for your hobbies. But the idea is we are addressing and we are targeting different vertical markets with this Nucleo ecosystem. So these are, again, marketing slides that can really highlight, how we believe it's easy to move from a rapid prototype and proof of concept enabled by our Nucleo board and the expansion board till the final form factor where density comes into account, the expertise and maybe the team that you are working with, and you, of course, require different expertise. But at least we believe that the first step to prove that the idea is viable, to develop, a proof of concept, not for factor board, this can be done pretty easily and quickly. So I think that's it. So I don't want really to bother you with too many information. These are just, exactly some additional, slides. The takeaway can be really, please feel free to use our Nucleo board, feel free to use our expansion board for the Nucleo. And now I let you, Slim, go ahead, and then we will be more than happy to reply to any questions we come up later.
Thank you, Eduardo. So, hello everybody, and welcome, and thank you for giving me this opportunity today to do this presentation. So, do you hear me okay like that? Yeah, that's fine. So, feel free to interrupt me anytime during the presentation if you have any question or anything like that.
I admit to being acronym challenged, especially in this embedded community. What is MEMS? MEMS this and MEMS that and
MEMS,
the other.
Microelectromechanical system.
Thank
you.
So,
sorry, yeah.
Okay. So, how many one of you is familiar with embedded development? Okay, good. So, during this presentation, I will introduce the STM32 Cube and Mbed and all these tools. So, basically, STM32 Cube is a combination between hardware, software, and firmware. So, the hardware basically is the STM32 Nucleo boards, but it's not only limited to the Nucleo board, also can be used with our Discovery board or our full eval boards. Plus, also we have the Cube MX, which is a software tool that allows you to select the microcontroller, select the peripherals, select the middleware that you want to use, configure the clocks, peripherals, and also generate the source code for you, and also select which tool that you want to use, so the IDE, and will generate the necessary files for that IDE, and you will get to app running very quickly and very easily, without going on details on how to set up the registers and all that stuff. So I will be doing a brief presentation on also the Nucleo firmware library, and we'll do also a presentation, live presentation. So all the embedded software also we deliver is developed per series, like the STM32 F4 series, F2, F1, F0, and L0. So all of and F3. So all of these are covered by the firmware. And also, so we provide the hardware abstraction layers, plus the middleware series and stack, like real-time operating system, USB library, USB host, and USB device, TCP IP, graphic, and multiple middleware libraries. So you can get the STM32 Cube from st.com. So I think the easiest way is to go to st.com and type STM32 Cube in the search box, and then you will get all the links that you need to download, all the software and everything. So the STM32 Cube firmware package. So basically, we have a package per family. So, for example, for the F4, F2, all the families. So for that, we have a hardware abstraction layer. So where we abstract the peripherals and like clock, GPIO, timers, A to D. So we provide a hardware abstraction layer. and so we'll provide a common abstraction layer for all the peripherals, for all the microcontroller families. On top of that, we have middlewares like networking, so basically the LWIP stack for networking, USB, graphic, fat file system, and RTOS, so it's the free RTOS. And on top of that, we have board support packages for the evaluation board, for the discovery board, and for the Nucleo board. And also we have some files like utilities, and the synthesis is for the Cortex-M microcontrollers. So it's a common library for all the Cortex library. Yes.
Would you explain the difference of the three board types?
Three board types. Okay. So the Nucleo board is this board, this form factor, where it's we have here the Arduino compatible pinout, and it's a very simple board. So here basically we have the microcontroller, two buttons, so a user button and a reset, and an LED. And so this bottom part is just the debugger, so it will allow you to download the firmware and debug it. The discovery board is more richer than this one, so we have like codec, audio codecs, and sometimes we have USB and things like that. And the eval board, so will expose all the device peripherals and features, and it's more richer and bigger board. So the STM32 Cube library, so structure will look like this one. So it's STM32 Cube underscore firmware underscore. So here will be the family. So this one F4 or F0 or L0 or L1, and followed by the revision, so X, Y, and Z. And then you will have the documentation for that library. The drivers, so here we'll have the board support package, the synthesis library, and the hardware abstraction layer for that specific device or family. And then you will have the middleware library, where you have the middleware libraries that are from ST, like ST which is the graphical library, audio library, USB device library, and USB host library. And also we include some third-party libraries like the fat file system, FreeRTOS, LWIP, and Polar SSL. And also with that, we have a project directory where we offer multiple examples per evaluation board that we have. So there you can expand that and you'll see multiple examples. So we have examples that are targeted for the board itself, and some examples to show you how to use a specific peripheral in a specific way. So this will give you more ideas on how to use the library and how to use the peripheral. So example for the evaluation board. So here, for example, for the evaluation board, we have a camera. F4 evaluation board, we have a camera example. For the display, for the fat file system, so with very advanced examples. And also we have examples for every peripheral. And also we have a template directory where we offer project templates for some specific IDEs like IR, Kyle, Atomic, so different IDE, so that you can get you starting very quick and easy. So for the STM32 Cube version and naming, so as I said, is STM32 Cube underscore firmware, then the product family followed by the revision number. So we every STM32 Cube have its own revision number, and STM32 Cube firmware, so its packages are maintained in a regular way. So we can have some full releases, so of a new library when we add the new features, or we have patches when we have some minor fixes. And also, so we're using the STM32 Cube MX, which is the PC tool. So the tool will give you a message whenever there is a new update to the library, and you will be able to download the new library whenever there is a new update. So to do that, you don't have to go like to the st.com or anything like that. So the tool will be able to update the firmware automatically for you. So for the STM32 Cube, so documentation, we have multiple documents. So like getting started, so we'll get you started with a firmware package. Developing how to develop an application with a FAT file system using the RTOS, the hard driver, the hardware abstraction layer, the USB device, USB host, Polar SSL example, Ethernet example. You know, you will have multiple application notes that show you how to use this multiple libraries.
I didn't catch. What is this notation 14W14, 14W15?
Okay, so this slide is a little bit also will be available week 14, 2014. Okay.
Does that HAL cover?
Sorry?
Does the HAL cover the wide variety of devices that STM?
Yes.
provides,
Yeah.
or is it just-
So basically, all the devices are covered with this hardware abstraction layer.
Okay. So 14W13 means it's already available, right?
Yes. Yeah. So these are already available.
So we're in 7W15 now?
Yes. Or the other way, it's you know, they're a little bit confused. So maybe that's the year week 14. So.
So what about GSM modem, for example, send SMS or make calls?
So for that, I will keep it later because we don't have GSM modems, but I will show you that, you know, or we'll show you how to do it with the Mbed, because with the Mbed, you know, you can do more things. So the hardware abstraction layer. So the hardware is abstract, allow for, you know, friendly portable APIs with multiple you know, devices. So if you want to change from one device to another, it would be very easy for you, so you don't have to rewrite a lot of code. And so the hardware abstraction covers all the peripherals, you know, including the advanced peripheral like USB, Ethernet, and, you know, which require, you know, more a higher level stack. And also the hardware abstraction layer comes with a lot of examples. So as I showed before in the library structure, directory structure, so there are a lot of examples, you know, simple examples and more advanced examples. And all of the code is in C, so we don't use any C++, but still it's C++ friendly. So if you want to use C++, so also you will be able to do that. So the hardware abstraction layer also supports 3 programming models, so like polling, interrupt, or DMA. So depending on how you want to use the peripheral, so you will be able to use this different methods. And also the APIs are RTOS friendly, so means they are reentrant functions. And also you will the peripherals, so you can have multiple instance support for peripherals like UART, timers, you know, SpyPort or HPC. So I will give later a quick example. And yes?
Can I implement interrupts and DMA access from one port to another?
One port to another?
I mean, like I'm looking at the Nucleo and
Okay.
if you're on Arduino account, so
Yes.
I want to put a shield on top of that. Can I interrupt or do DMA from one one to get through that now?
Yes, yes, yeah.
Okay.
Yeah, so yeah, interrupts are supported. Even you can use a GPIO, signal. So on a GPIO or the peripheral can generate interrupts, and also we on the hardware abstraction layer will give you callbacks.
Oh, sorry, what do they tell them to do that?
Yes, so you will have a callbacks where you can implement your function. So when there is an interrupt, so you have your callback, and you can write your interrupts. Okay.
So for the DMA, you'll give me back the address, I'll write that address.
For the DMA, basically, when you configure the DMA, you should give it the address where to write to or where to read from. So basically, you will have an array or something like that, and then you pass the address of that array to the DMA, and then the DMA will take care of that. So at the end of the transfer, you will get the interrupt. So for example, you are reading, so you will get the interrupt, and then on the interrupt service routine, when you are there, you know that your buffer is full, and you can process that data. So we have multiple callback functions. So for the API, so you will have a peripheral init function to initialize the peripheral. You will have a dinit, so to reset the peripheral to its reset state. And also you have user callback functions to do peripheral system level, like interrupts or error handling. So the callbacks will be for peripheral interrupts event and error events. For the peripheral hardware abstraction layers, so you will have files like that STM32. So here will be the family. So here, for example, F4 or F0, or any peripheral family. HIR underscore. So the PPP will be the peripheral name, like GPIO or TIM or timer or ADC. So that will tell you which peripheral. So these are for the peripheral, the driver with protocol APIs. And some peripherals, from one device to another, they have common functions, and sometimes they have extending functions, like they are not available in the other families. So for that, we have the _exe for extended peripheral features API that are not present in all the devices. Then we have the STM32 family name HIR.C, so that contains the hardware abstraction common APIs like init, dinit, and like delay function. So that's the header file. So that's what you should include in your main. So that's the only file that you need to include in your main. We have a configuration file where you can configure your library. And def.h, where it contains common type defs and macros that are used within the library. And sometimes we have the _LL for low level. So when there is more complex peripheral that require more, complex functions like USB or camera interface, or for example the Ethernet. So you will have them and implemented on a different function. So from the user point of view, so the only thing that they need to include is the STM32, for example, F4_HIR.h. That's the only file that need to be included in your project. So then we have STM32 F4XX_IT is for interrupts. So there where all the interrupts are handled. But still, you don't need to change that file, because you will have some callbacks that are they are already declared on the library, but they are declared as a weak functions. And only thing you need to do is to redefine these functions. So the hardware abstraction layer, so we'll have the configuration file, and also you will have the peripheral hardware hardware extension layer for every peripheral. And then the synthesis library, so that's common also for all the devices. So where you have system underscore STM32 F4, for example. So that's file the system is, you will have basically the clock configuration function. So that is executed the very first thing when the microcontroller starts. So the very first thing we do is initialize the clock. So we will have a fast clock at the very beginning of the, when the microcontroller starts, and then you will have, the compiler, the linker added functions like to initialize, the memory, and initialize the stack and heap and all that stuff, and then you will jump to your main application. So for the hardware abstraction layer common APIs, so we have the hardware HIO underscore init, so it needs to be called at the application startup. So we initialize with data and instructions, cache, for the flash and all of that. Set the system timer, so we will have a tick timer for your application. Set the priority for the interrupt controller, and also call the MSP init function, which is user callback function to do system initialization like clock, DMA, and all that stuff. The gainit, so you call it when you need to reset all the peripheral, and then you have get tick, so we'll give you the system tick counter, and the delay function. So when you have to introduce a delay in your application, so all you need to do is to call that function with and you specify the delay as a parameter to that function. So these are some examples for the peripherals. So like the RCC, the reset and clock control unit. So this is used to set the clock and the system speed, the PLL for the device. So we set the system clock, the APB clocks, and flash wait states and all that configuration. For example, for GPIO, you will have the GPIO init, the GPIO tick init, read pin, write pin, and the toggle pin. So this, to read and write to GPIO peripheral. So if you want to use the GPIO in interrupt mode, so you need to, I will show you, how to set GPIO in interrupt mode, and then you need to call the hardware abstraction layer GPIO EXTI ARQ handler from the interrupt file, and then you implement the callback function, the GPIO EXTI callback. So this function is declared as a weak function, but you can redefine it later on your main application.
Suggestion, you
Yes.
may want to clarify the weak function because it's not very commonly used in many.
A weak function.
Yes.
So the weak function it's a function that is already been declared, but you can declare the same function with the same name, same parameters, and everything. So the compiler at the compile time or the linker will use the new defined function in your already defined function. So because if you don't define it and the function is not defined at all, then you will get a compiler error. So it will tell you, okay, you have this call to this function, but I cannot find it. So the function is there. I can show you later on the demo. Okay? Yes.
What is analog mode for GPIO? Analog means what?
Analog. So analog is when it's used by the ADD converter. So when you want to convert an analog signal with the ADD converter, or if you want to use the DAC, if you want to output an analog signal. Because the GPIO, they will have multiple modes. So basically, I can separate them in 3 major modes. So analog, so to read or analog signal to convert it to a digital value or to output an analog signal. Inputs, so to read the the signal coming from like an interrupt coming from sensor or something like that. Or output is as output push pull to drive an external signal like turn on or off an LED. There is another mode is called alternate function. It's used when you use a peripheral like a timer to generate a PWM signal, or like UART for the serial communication or things like that. Then you will need to use the alternate function. Okay. So don't worry about all of that, because this will be done automatically for you with the CubeMX software tool. So the same thing for the DMA. So we have multiple functions for the DMA, like init, deinit, start. So you call start when you're gonna use a polling mode, and if you want to use the interrupt mode, so you need to call start underscore IT is for interrupts. You can abort the communication. If you need to call for transfers, that's a blocking function where you need to wait until the end of the transfer. DMA RQ handler, so to handle interrupts coming from the DMA. And also we have functions to get the DMA status, and if there is any error, to get the DMA error and to see what's going on. For the NDIC is for the nested vector interrupt controller. It's the interrupt controller. The same thing. We have multiple functions that you only can use to set the interrupts for the peripherals. And the SysTick is for the system timer. So where you can configure the system timer, and this for the configuration, and this one is to set the clock for the system timer. Also, we have other set of functions for power management. So the PVD is for the programmable voltage detector. So I'm not going to go on details on that because this will take a lot of time. For low power mode is to enter in sleep mode, to enter in stop mode, or to enter in standby mode. So if you have any questions about that, so we can keep them after the presentation, and I can give you more details on this mode, and if you want to understand more, I can give you more details. So for the peripherals, like timers, UART, this we have another driver model. So it's based on a handle structure. So a handle structure is allocated for each instance of the peripheral, and so the handle structure will allow you to set particular parameter for that peripheral. So for example, here we have for the UART, for the serial communication. So we have the instance of the handle is UART type there, so it's a pointer to the UART registers. We have the init structure, so where you can define how you want to initialize your peripheral, like for example for the UART, like the baud rate, number of bits, number of stop bits, things like that. And then you will have you will specify. Oops. You will specify to a pointer to the transmit buffer. You will specify a pointer to the receive buffer, and then you specify the transmit size, the receive size, and all that stuff. And also, so we have a lock object. So it's when the peripheral is in use, so you can lock it. And also for if you want, if the DMA is used, so if you want to use the DMA with that specific peripheral, also we have 2 pointers for the DMA initialization. Yes?
Is that transmit buffer and receive buffer, is that internal RAM or is that external RAM or memory?
So for the microcontroller, basically we have the internal flash and the internal RAM. So basically these, these buffers are internal. But in some devices we have external memory with the external memory bus. So it's possible to extend your memory with an external memory, and also you can use that external memory to put your buffer.
So that pointer to transmit buffer would know where that memory is located? Or
Yeah. Basically, what we do is we define a table with the size, maximum size, or that you're gonna transmit or receive, and then we pass, the address of that table to this structure.
Well, I think maybe, I don't know, maybe I'm wrong, but the question is, are you using that with the heap stacks or are you using that with a new statement? So, I mean, is it static binding or dynamic binding? We can use from either both.
Yes, you can either one, yeah.
Okay, so.
Yeah, if you want to use, dynamic, like, if you want to use the heap, you can do that.
Okay, you can use it with a new statement.
Yeah.
Okay,
Yeah.
all right, so either way.
Okay, no. That's C, that's not C++.
All right.
Yeah, there's no new statement on there.
Right. Okay, so you can't use it with new. All right.
Yes.
So it's malloc.
Malloc, yes.
Yeah.
Malloc and calloc, yeah. Yes. Okay. So the same thing, for the abstraction layer. So we have init, dinit, receive, transmit. So for example, here transmit with the DMA. You have multiple functions that allow you to do, to choose how to you want to use that peripheral. Okay, so this one is for the user callbacks. So you have, for the peripherals, so you have process complete callback or error callback. So you define per peripheral, so, and when there is when end of transmission or end of reception or something like that, you will get the interrupt, and the firmware will jump automatically to that callback function. Also, we have different type of functions, so blocking or non-blocking. So it depends on how you want to use the peripheral, so we can use different type of functions. Okay, so I will present the Nucleo board. So that's the Nucleo board. So here on top, so this one. So here we have the USB communication. So this one is used for debug and also used to provide power to the board. So here we have the integrated ST-Link. ST-Link is the debugger, so that allow you to upload, download, the new firmware, debug it, and do all of that. And also, it's when you plug it in your computer, you will see it also as a mass storage device, like you have an external hard drive. We use it for Mbed. So I will show you Mbed and how that works, and why we have it's seen as a mass storage device. You cannot save files there or read, but it will be seen as an external mass storage device. And also we have with this is also will look like a virtual COM port, so it will be seen as a COM port on your PC. So you can use like softwares like Hyperterminal, I don't know if it exists anymore, or like teraterm or things like that, to send and receive over data over the serial port. So also you have two buttons, a reset button and a user button, and also you have an LED. So that's LED2. So this one is a user LED, so you can toggle it. And also here there is another LED, but this one is to show you if, the power LED, if you have power to the device or not. And then we have two connectors here on the side. So these are Arduino compatible connectors. So you can plug in any Arduino shield there, so it will work. And also here, since the Arduino works, the Arduino connector, they don't expose all the device pins. So we have this extra connector. We call them Morpho connector. And also, this, the pin out here is common for all the devices. So if you develop any, let's say, shield that use the Morpho pins, will work on any Nucleo board.
How much current can you drive with the GPIO and the pulse width modulation?
With pulse width modulation?
And
so most of the GPIO are you can source or sync up to 25 milliamps.
So now we'll get it once, right?
Yes, I think it will depend on the device, but I think the maximum that you can source or sync is 80 milliamp total. And so 80 milliamp total, and the microcontroller in general is maximum 120 milliamp.
And can I provide an external 5 volts input if I want more power to the USB?
What do you mean?
If I need more power to a USB, can I put more in?
Yes.
Okay.
Yeah. So here you have the 5 volt, and the USB can provide up to 500 milliamp, and you can do that. And also here, if you see, so you have in the power you have the 3.3 volt, and also you have the 5 volt that is coming from the USB. And also most of the GPIO, so the microcontroller is 3.3 volt, but most of the GPIOs are 5 volt tolerant. Means that you can input a 5 volt, on the pin without the need, to drop that signal to 3.3 volt without the risk to damage the device. But still, the device is 3.3 volt. So the analog pins. So here we see the analog pins that are used by the ATD converter. So these are not 5 volt tolerant. So there you can put only 3.3 volt maximum. But for the other GPIOs, so you can put input up to 5 volt without the risk to damage the device. So for the device, so this will be the STM32 microcontroller. So we use 64-pin packages. I think we have 64-pin packages for the whole family. So basically, if you STM32 family, so from the M0, M3, M4 are pin-to-pin compatible or very close pin-to-pin compatible. So sometimes there are some differences. But if you use the 64-pin package device, basically anytime you can pull that device and put another one in there and will work. So you will have the same pin out, the same, everything. So because they are pin-to-pin compatible. So that's why, you will see all the boards there. You have the same, same layout, same everything. And here what we do is just change the device. And also I already covered the Morpho header. Okay. So here when we do an example, so I will show you the Cube MX and how to use it. So I will use the LED one. So the LED here, in fact, is LED2 that is connected to pin TA5 on the microcontroller.
Before we get to the demo,
Yes.
I want to make totally clear.
Yes.
Your development environment is always Windows. You can't develop under Mac or Linux or something out there. I mean, I'm getting these from hints,
Okay.
such as this weak pointer, weak thing, which is not standard.
Yes. So most of the softwares are Windows. Yes.
But you said GCC is an option. And I can target ARM on my GCC and cross-compile from whatever machine I want to, right?
Yeah.
So,
Yeah. And also, yes.
Talking about the development environment, not the target environment. It's different.
Yeah. So there are things that are provided by ST and things are provided by our third party. So ST is, the firmware and the Cube MX and the STM32, the Nucleo board, and then you need the IDE, which comes from third parties. So like IR or Kai, which is ARM, or Atomic, and these guys, they may have multiple environments that may work on only Windows or Windows, Mac, and Linux. So that's
The software that your company provides
is Windows.
runs on Windows.
One runs on Windows. Yes.
Let me be clear.
Yes, runs on Windows.
I got that only from hints.
Yes.
Like these non-standard.
Yeah. It's only Windows.
All right.
All right.
Unfortunately, weak keyboard is
Weak.
not available.
Weak is only Windows. Weak.
No.
Hmm?
Weak keyboard is not available in Microsoft Linker, which I personally miss a lot. It comes from the compilers which are specific to embedded world. You cannot use weak keyboard in big
Okay.
compilers in Linker.
This is. I assumed that weak was something because weak is not part of any standard that I know.
Yeah.
Weak function?
Weak functions are not part of any standard that I know. So I assumed that it must be Windows since I'm not.
No.
I'm not a Windows.
No. That's the compiler. No. It is C standard. Weak function.
In the C standard?
Yeah.
No.
I don't know about
I don't think so.
PC. For embedded, yes.
It's
It's
an
an extension.
extension. It's an extension used by the embedded world
I
and
think
not
so.
known by anybody else.
I think
Maybe yes. No, yes.
Linkers on Linux,
Yeah.
you can define weak functions.
Yeah, if it runs under C, you
Yeah.
compile.
I mean,
That's the
it's
standard
the
right
linker,
there.
it's not the compiler.
Yeah.
Yeah.
Right.
So how do you specify a weak function in the compiler?
Well, in a real computer, you would use a shared library, and you load it at runtime, basically. Because at compile time, you don't know what the function's going to be, right? Or on Windows, it'd be a DLL. So you're going to have a weak link, a weak symbol.
So if you don't define this function in your project, it's taken from the library.
Well, I think you're going to tell it that it's weak, and I mean, usually the compiler is magic.
You can tell it.
This is how we define it.
You can tell it how, but not.
Doesn't weak have a bunch of APIs you can use, correct?
Underscore.
Yeah,
weak.
it's going to be
Bunch of
platform.
APIs you can call up.
Yeah.
So you just pass it the right parameters and voila.
As part of the C99 standard.
I think yeah.
All right. I will look it up.
Yeah. So all you need to do, if you need to redefine this function, is just redefine it, and the linker will, or the compiler will pick the new one. And in your case.
All right. I'll look it up.
Okay. Alright. So the Cube MX will look like that when you start it, so we can start the new project. When you start a new project, so we get the MCU selector, so you can select it with using multiple filters. Here I will be using the Nucleo F072RB, so which has STM32 F072RB. So I will select F0, 64-pin package, and here we go. So that's the device I'll be using today. So just double click. Okay, and then we get this window. So here you will see that the peripherals, all the peripherals that are available. So you can, for example, you select timer, you know, okay, for example, you set input capture, and you will see here that this pin input capture is already being selected on the device. Okay. So we'll show you the pin position, you know, and everything is here. So I'm not gonna use it now. So just to show you how it's working. For example, if you want to use FAT file system, so you can use the, you know, enable the FAT file system. If you want to use the FreeRTOS, also you select I want to use the FreeRTOS. So you can do things like that. So the same thing, you know, if you want to use the ADC, let's say you want to use the ADC channel 0, use just ADC and select that, and then, oops, voila, you will have it here selected. Okay? But today I will be just showing you, I'm going to cover just the LED, which is connected to PA5. So it's easy to find. So here we have the find box. PA5. Oops. PA5. And here is PA5. Okay? Click. And also, since I'm going to be driving the LED, so I need to set it in output mode. Okay? So now that pin is selected, so whatever you select, any peripheral, so it will be a very similar way. So now I'm done with the GPU selection and peripherals. I can go to the clock configuration. So this one will show you the clock configuration for that specific device. So I will be using it. So it depends if you want to change the clock configuration or no. So you can keep it as is, or you can change it. So here I will change it. So I will use the internal oscillators. I'm going to enable the PLL, and I will use the PLL multiplied by 6. And here you will see that my system will be running at 48 megahertz. And then I can go to the GPIO configuration. So for, here if you use, other peripherals, so they will show here, so they will be configured in the same way. So here I have the GPIO, as you can see it here, the GPIO PA5 is selected. I can see here the mode is input mode. You can set in pull up, pull down, all different configurations that are possible. And also here you can give it a name. Say, you can name it like 82, for example. Okay. And then, so if I go back to the pinout, I can see that is here it's named 82. Okay.
Why did you have to set a clock? I mean, you're not going to do anything. Why did you have to set a clock?
No, just showing you, you have that option, but I'm not going to do anything with the clock. Okay, clock configuration, and also this tool can offer you, you can estimate the power consumption of your application. So that's I'm not going to cover that today. And then here you can click, and then we'll give you, the option, to generate the project. Okay. For example, LED here, and also so here the different tools that are offered. So I'll be using the MDK, which is the kite tool. So here you see there are 3 different tools. So E1 is the IR tool chain. MDK, just one second. MDK is the kite, and QStudio is based on Eclipse and GCC. So all of 3. So basically, they offer evaluation version, which is limited. Like you can have it limit up to 32K of memory, flash or code memory, or unlimited, but for period limited. But now Kyle, they offer specifically for the M0 based microcontrollers, STM32 F0 and L0, a free IDE complete, so it's can use without any restriction. So, and I will be using Kyle today to show that that demo. Okay.
Yeah, you hit it.
Okay. Okay. Using ARM. So here you can choose to copy all the libraries or only copy the necessary libraries. So you have multiple options for generating the code. Click OK, and now code is being generated. This is just my laptop is slow.
Windows operating.
No, no. My laptop.
You configured your GPIO being as an input. Actually,
No, output.
It was an output.
output. Okay.
Output.
This has been tried.
Okay, so now the project is generated. So I can open the folder or open the project or just close this message. So I'm gonna open the project. So now this is Kyle and that's the project. So it's LED configuration. So here, okay, application, and that's the main application, and you have all code is generated. So here you will have the clock configuration, and here you have the GPIO configuration is already configured. So it's pin 5, GPIO pin 5, and it's input. Oh, okay.
Is there any way to get this generated code and imported?
GPIO input.
Question.
Yes.
I'm presuming that this is one-way operation, or is it possible for this environment to actually read the generated code and recreate the diagram?
Okay, I'll show you after it's generated. Okay. Okay, open project. That's the project. Here. Name. So you see, to answer your question, user code begin and include private variables, functions. User code begin 1, 2, and big 3. So whatever you put here inside these will be preserved. And also, if I go back to the Cube MX here. Anyway, so when you set up the project, when I said, I put the project name, and also I put the tool and everything. Also there is the option, so they have a checkbox if you want to preserve the user code that is already being created or not. So you have the option, to preserve it or not. Okay. Alright. So we see the different, you see that the device, we have the correct device. For the debugger, we have the ST-Link is already checked. So we are connected, so everything looks okay, so we don't have to do anything. Now I'm gonna build the project. We're gonna add something here. Okay. Good. So now that's the board. You will see here, so this LED will blink. So we are flashing the device. So here you see that it's being programmed. Okay, now we are on main, and then I'm gonna run the project, and the LED should be blinking. Okay. So I can set the breakpoint. So here I have the breakpoint. So, and that's how it's.
How many lines of code is that file?
Hmm?
How long is that file?
This one?
Yeah. Less than 200 lines to look away. That's not bad.
You could do it in few lines. Okay. So, I'm not going to go a lot of details now on CubeMX, so I will do now. I will switch to Mbed. I'll show you Mbed and a quick presentation of Mbed. Okay. So Mbed, same thing. So in fact, Mbed is an IDE. It's a web-based IDE. So you use your favorite, web browser to compile, to build and compile your embedded application. So all you need to do is the Nucleo board and the USB cable and a laptop with the web browser. So, for example, if you want something like this one, like you have a sensor, and you want, to monitor something on the web, and you want to, to do an internet of things, something that is connected to the web. So sometimes it seems hard, it's going to take a lot of time, it's difficult to do. That the reality, with all we have now, with all this ecosystem, is very easy to do, and also it's like in 30 minutes, you will be sending data to the cloud, to the server and access it from the web. So you need to go to mbed.org. You create an account. You have Nucleo board, with connectivity boards, so it can be, you know, GSM based, or Wi-Fi, or Bluetooth, or anything like that. So you add it to the board. You add your sensors. So for example, here I have a humidity sensor, and I have a Wi-Fi shield that's connected. And then, for example, AT&T, they offer web services. I think they're still free to use, so you can go there and create an account and start using it. I will give you where to go, exactly where to go to find all the information on how to do that, how to build and how to do that. So you can have these kind of things like your creature and start sending data to the web, and doing graphs and things like that. And also you can build an application, phone application, to gather that data and see it on your phone. And also I think you can even send commands to your application. So we have a lot of shields, so Bluetooth, energy, cellular board, NFC, other type of radios. So some shields are from ST and some others from other third parties. So and there are a lot of that are supported by Mbed. And also there are sensors, a lot of sensors that that are available. So we have boards like that with sensor. You just plug it in, and you're ready to go in a few minutes. Okay. So it's mbed.org. Only you go to mbed.org, and so if you want to know how to create your to make your the thing to connect it to how to send data to the cloud for the AT&T web services. So search for STM32 hackathon. In fact, we did that for a hackathon that we did with AT&T in Las Vegas, last month. And so if you go there, so you will be directed to this website, and here you will have a lot of examples on how to use Mbed and that shield. And for sending data to the AT&T, so you go here, getting started with AT&T M2X. So if you click on that, so you'll have all the details on how to connect to AT&T web services and start sending your data to the cloud. Okay, I will go back to Mbed. So it's mbed.org will look like that. You go to the developer site. So I'm already logged in. So then you select platform. So there are multiple platforms, but of course select ST Microelectronics, and there you will see all our boards, Nucleo boards. So today I will be using the F072, this board. So you click there. So that's the description of the board. I'm not going to go into the details. And then, so if it's not added to your Mbed compiler, you can click here and add it to your Mbed compiler. Okay, so that's added. You can remove it, but I'm not going to do that. And then here you have, on the side you have multiple examples. So today I will be doing the Nucleo printf example. So I click that. When I click that, so I get to this page, and then I click import program. So once I do that, so the Mbed compiler will open. Okay, I'm not going to name it. So import. Okay, so that's the project is already imported. So here you see on the up right corner, you see my my board. So you can change that board if you want. So here you have multiple boards, and you can choose from. Today I will be using this board. And then you hit compile. So in the meanwhile, I'll open term, so serial. Here you will see the ST Microelectronics, virtual COM port. That's the COM port that is coming from this board. So I'm gonna select it. Okay. So that's okay. So it's okay. I don't know why. I don't know why it's doing that, but it should work. So that should be this main program. So here, for example, this one is, I know that it works. Okay, success. It's the same project. So this one was compiled for the F4 Nucleo board. So I'm gonna change that to my board that I'm using. So it's just, select the new platform, recompile it. And then, so at the end of the compile, so we'll ask you to download, to upload this file, to download this file. So all you need to do is to download. Here you see on the computer, you see Nucleo, select Nucleo. So that's, as I said, the Nucleo board will be seen as a hard, external hard drive. So you select it and select save. When I do that, you will see the ST link will be blinking. And then, okay, it's blinking. And the term is displaying the message. Okay?
I'd like to make sure I understand the process from the beginning.
Yes.
Let's say I'm a company here in Seattle that grows pineapples, right? So halfway around the world is where I grow the pineapples, okay? So that I can take this device here and have it in a data logger, right? And have an analog sensor sense the
humidity,
moisture content of the soil.
Yep.
And anytime, 24 hours a day,
Yep.
I can get that. That's what I can do, right? It's going
Yeah.
Yeah, if you have satellite with internet, you could do that, couldn't you?
Yes. So
very cool.
Yeah.
They're doing something like that right now with HIV. You'll be able to detect HIV through your smartphone by taking a simple prick of your blood and come back and tell you if you got, well, I don't know.
Yeah.
If you really want to know, but you'll go do that.
Yeah. So let me show you. So even if you go to this one, you see this one, the U-block cellular module.
Yeah.
So that will show you how to add, cellular module and start sending sensor data to AT&T M2X web service.
So each one of these has a unique address. Each one of these modules that you
Yes,
can access
yes.
to the internet.
Yeah.
Is it something like a 64-bit address, which would make it almost impossible not to duplicate type?
Yeah.
Okay.
Yeah, and it's very easy to do. If you have this building, this blocks, 30 minutes you will be sending data to the cloud.
Is it expensive hardware?
I don't know.
I don't know about the U-blocks, but
I don't know.
Ours hardware is pretty low cost.
Yeah.
The STM32, I think like you were saying, was going to be $10 to $25 for the STM32.
Yeah.
Do you have anything else on there that's
Yeah, there is simply two view blocks, and then if you want, you can add sensors like this one. So this one I think it's humidity sensor.
Yeah.
And there are examples, how to read from this humidity sensor and then send the data. So let me see here.
Tell you what, folks, we're running a little bit over time, so I think let's go ahead and kind of wrap up the formal meeting, if that's okay with you. And if anybody wants to hang out and chat, we'll do that.
Perfect.
Okay.
Just let everybody still go.